Across the factory floor, a relentless heart beats. This is the boiler, the unseen titan generating the power that drives civilization. We delve deep into the critical functions of industrial boilers, understand how these powerful machines convert mere water into unstoppable kinetic energy. The fundamental purpose remains singular: steam generation. This high-pressure vapor is the lifeblood of almost every heavy industry worldwide. Boilers are sophisticated heat exchangers. They transfer immense thermal energy, derived from combustion, directly into the feedwater system. This conversion is not passive, it's tightly controlled. Precision engineering ensures the water reaches critical pressure and temperature points safely. Without efficient steam generation, production halts. The boiler ensures continuous, scalable energy supply, matching industrial demand flawlessly. The energy contained in steam is vast. Just 1 cubic meter of water can expand into thousands of cubic meters of usable, pressurized steam. The resulting steam can be saturated or superheated, each serving a distinct industrial role based on its temperature profile. Saturated steam is often used for direct heating and sterilization processes, demanding consistent thermal output. Superheated steam, devoid of excess moisture, is crucial for driving turbines, achieving maximum kinetic efficiency in power generation. Function 2. Electrical power generation. Boilers are the primary heat source feeding steam turbines in thermal power plants globally. The kinetic energy of the expanding superheated steam rotates the turbine, which in turn spins the generator, producing electricity. This reliability is non-negotiable. Baseload power often relies entirely on the continuous, unwavering output provided by large utility boilers. Function 3. Process heating. Many manufacturing sectors require heat for chemical reactions, drying or melting raw materials. Industries like food and beverage, pharmaceuticals, and chemicals depend on precise, sterile steam heat for product integrity. Steam provides superior temperature control compared to direct flame, preventing hot spots and ensuring uniform processing across large volumes. Function 4. Mechanical drive. Before electric motors dominated, steam engines powered everything, and boilers still drive essential large pumps and compressors. In refineries and petrochemical plants, high-pressure steam is essential for cracking crude oil and driving complex separation processes. Function 5. Humidification and HVAC. Controlled steam is used in large commercial buildings or specialized environments to regulate air moisture. This diverse utility proves the boiler is not just a heater, but a central utility provider essential to infrastructure integrity. The furnace, or firebox, is where the fuel meets oxygen and ignites. It must withstand extreme temperatures, often exceeding 1,000 degrees Celsius. The integrity of the furnace lining, typically refractory material, is paramount for safety and efficiency, isolating the heat within the chamber. The burner assembly controls the fuel introduction, crucial for maintaining the precise air-to-fuel ratio necessary for complete combustion. The boiler drum acts as the central hub, separating steam from water and collecting the saturated steam before it is dispatched. This drum often contains internal separators, like cyclone separators, ensuring only dry, high-quality steam leaves the system. Water tubes or fire tubes facilitate the heat transfer. The design dictates whether hot gas passes through the tubes or water flows through them. Water tube boilers offer higher pressure and capacity, ideal for massive power generation where intense heat transfer is required. Fire tube boilers are smaller, simpler, and usually utilized for lower pressure steam requirements in packaged units or small facilities. The economizer is a critical component recovering residual heat from the flue gases before they escape the stack. By preheating the feed water, the economizer significantly reduces the energy required in the main boiler, boosting overall thermal efficiency. The superheater takes saturated steam and raises its temperature substantially without increasing pressure, creating the necessary superheated steam. Proper superheater function prevents condensation in the turbines, safeguarding delicate machinery from erosion damage. The blowdown system is essential, removing accumulated mineral deposits and sludge from the boiler water to prevent scaling. Scaling reduces heat transfer efficiency dramatically, acting as an insulating layer between the heat source and the water. These components work in synchronized, relentless cooperation, forming a system engineered for decades of powerful, continuous service. Water tube boilers are the behemoths of the industry, capable of generating millions of pounds of steam per hour at extreme pressures. Their design allows rapid steam generation and response to load changes, vital for fluctuating power grid demands. Natural circulation boilers rely on density differences between hot and cold water for flow, simple yet effective for medium pressures. Controlled or assisted circulation uses pumps to push water through the tubes, enabling much higher pressures and capacity. Fire tube boilers, conversely, are limited in pressure capacity, but offer a larger volume of steam storage within the shell itself. They are often preferred in small to medium industrial settings, where instantaneous steam demand is predictable but not extremely high. Package boilers arrive pre-assembled, minimizing installation time and complexity, perfect for decentralized or rapid deployment scenarios. Field-erected boilers are constructed piece by piece on site, reserved exclusively for the largest scale operations, such as central power stations. Fluidized bed combustion boilers burn fuel efficiently by suspending particles in a high-velocity airstream, often capturing pollutants. FBC technology is key for burning low-grade fuels like biomass or waste coal, broadening the usable energy resource base dramatically. Waste heat recovery boilers are deployed in industrial processes like gas turbine exhaust to reclaim energy otherwise lost to the atmosphere. This is a crucial function of modern efficiency, integrating boiler technology seamlessly into existing industrial processes for energy maximization. Once-through boilers forgo a steam drum entirely, forcing water through tubes that convert it to superheated steam in a single pass. These cutting-edge designs push the limits of supercritical pressure, achieving incredible efficiencies required for advanced power systems. From the smallest modular unit to the largest supercritical giant, the variety reflects the sheer adaptability of boiler technology to global needs. Boilers must handle diverse fuels. Natural gas offers clean combustion and easy control, leading to high operational precision. Coal, though environmentally challenging, remains a potent energy source, requiring robust pulverization and ash handling systems. Oil firing provides a quick ramp-up capacity, often used as backup or in locations where pipeline gas supply is infeasible. The shift towards biomass, derived from agricultural or wood waste, promotes carbon neutrality, utilizing renewable energy sources. Multi-fuel capability is a key function, allowing factories to switch fuels based on cost, availability, and regulatory requirements. Thermal efficiency is the measure of how much fuel energy is successfully converted into usable steam energy. Achieving high efficiency minimizes operational costs and reduces the environmental footprint by burning less fuel for the same output. Modern systems use advanced heat recovery and optimized combustion mapping to push efficiency above 90% in many new installations. Function of heat recovery: capturing excess heat from the boiler stack and reusing it, sometimes for building heating or feedwater pretreatment. Every percentage point of efficiency saved in a massive industrial boiler translates into millions of dollars in annual savings. Boiler safety is paramount. High pressures and temperatures mean any failure is catastrophic, demanding rigorous safety protocols. Essential function: pressure relief valves. These mandatory devices automatically release steam if the pressure exceeds safe limits. Low water cutoffs immediately trip the burner if the water level drops too low, preventing catastrophic overheating and tube failure. Water treatment is a continuous function. Feedwater must be meticulously purified to remove oxygen and minerals that cause corrosion and scaling. De-aerators remove dissolved gases like oxygen and carbon dioxide, the silent killers that relentlessly corrode boiler metal from the inside. Regular maintenance and mandatory inspections ensure the structural integrity of the vessel and its piping under extreme duress. Tube cleaning and fireside soot blowing are critical preventative maintenance functions to restore optimal heat transfer surfaces. The function of monitoring is constant. Sensors track vibration, temperature, emissions, and flow rates, providing real-time operational diagnostics. Fail-safe systems are multi-layered. Redundancy in pumps, controls, and safety interlocks ensures that single-point failures do not cascade. This machine is not static. It is a dynamic pressure vessel, demanding respect, training, and constant vigilance from its operators. Smart boilers integrate IoT and AI functionality, optimizing combustion settings and predicting maintenance needs autonomously. Predictive maintenance replaces scheduled shutdowns, leading to maximized uptime and minimizing costly, unexpected component failures. Decarbonization function. The move to carbon capture and storage, or CCS, integrated directly with boiler exhaust systems. The future sees modular reactor boilers and advanced heat pumps supplementing or replacing traditional combustion, minimizing fossil fuel reliance. The boiler's function is evolving from brute force steam generation to intelligent, highly efficient, and environmentally responsible heat exchange. The unseen core of industry, the boiler's relentless work powers our world. If you found this journey into industrial titans fascinating, please show your support. Don't forget to like and subscribe for more updates.